as A, if I do the 4.5, the Y is less than 4.5. So I was wondering why I was getting a different figure from yours, because it's the same, but I saw in your video you said they were close.
Well, if you do the normal probability approximation with less than 5, right? So part A, you're supposed to compute the binomial distribution for less than 5. Then you do a normal approximation using the mean and standard deviation that you compute, from the n, and the pi up there is what they mean by that's their p, right? That's their probability of success. So of course your mean is going to be 10, and then your standard deviation is going to be the square root of 20 times a half, and go from there. So what's that? Square root of 5. And if you run the normal approximation for things less than 5, it'll be okay, but it won't be great. It won't be really close to the actual answer you get from the binomial. However, if you change it and then run the normal approximation for 4.5, right? Less than 4.5. So you're basically doing a normal CDF up to 4.5. Then your number should get better, and it should get pretty darn close. And the reason why this helps is it's the correction for continuity, right? It's the fact that the normal curve is a continuous curve, and the binomial distribution is a discrete distribution. And so if, when you're asking the binomial to find something less than 5, it's actually starting at 4. But the distribution centers the bar, if you will, the probability bar, right, right above the 4. So if you try and fit a normal curve over that binomial distribution, and you want to capture all of the area above 4, you need to start the normal curve at 4.5, because if you started at 4, you're only going to get half of that bar, because that bar is centered on 4, just like the bar for 3 is centered on 3, the bar for 2 is centered on 2, and so on and so forth. So if you start at 4.5, you're going to capture the entire bar for 4 and everything below it. Whereas if you start at 5, you're going to get all of 4, but you're also going to get half of the bar for 5, and that's why it doesn't work as well. As far as why you're getting a different answer in Excel versus something else, well, I know Excel does the inclusive versus exclusive thing, so that could be the problem that's going on there.
So could we try Excel and see?
Sure.
Okay.
Go over the last few questions from the final project, part 1, 2 through 5. Yeah, Melissa, yeah, we'll get to that. We'll do that next.
And Dr. McBride, you can do this in StatCrunch too as well, correct?
Absolutely. Yeah, StatCrunch is super easy. Yeah, so while my Excel is loading, in StatCrunch, we saw this before. We would just go to calculators binomial, right? If we want to do the binomial one, and it was 20 and 0.5, and they want to know the probability of being strictly less than 5, right? Not less than or equal to, but strictly less than 5. And so there's your answer. There's your precise answer from the binomial. Then you go to the normal calculator, and your mean is 10, and 20 times I have is 10, times I have is 5. Yep, so it should be square root of 5 is your standard deviation. And then if we use 5, we get that, which isn't great, right? I mean, we're talking about 0.0059 versus 0.016. That's not, fantastic. But if we go to 4.5, now 0.0069, that's pretty darn close, right? It's a lot better. So that's the whole point. In Excel, my poor computer is like, you've got too many things open. All right, so equals the binom, right? Dot distribution. And so the number S is, what we're the cumulative function. So if we're less than 5, we want to go up to and including 4, comma, our trials is 20, comma, the probability is 0.5, comma, true, because we do want the cumulative, because we want everything less than or equal to 4, because that's what gives us strictly less than 5. And there's that same number, 0.0059.
Yeah.
Now, if we want
this
to
one-
do the normal, equals norm dot distribution, the x value that we're using, well, if we start with 5 first, then the mean was 10, standard deviation is square root of 5, and then of course true as well, because we want it to be cumulative. And there's that same crappy, approximation of that. And then if we go up here and change it now to 4.5, we get that same 0069 better approximation.
Okay, I get it.
Okay.
Okay.
So the whole point of this question, the whole learning point of this question is to understand the correction for continuity. The fact that if you're trying to approximate a discrete probability curve with a continuous curve, you have to correct down, because you want to be able to pick up the entire bar for 4, but you don't want to start at 5, because that's going to give you half of the 5 bar. So you start right here at 4.5, and that gets all those bars and below.
Thank you.
Okay. All right.
Understood.
Absolutely. Fantastic. Okay. Melissa asks if we can go over the last few questions from the final project, part 1, 2 through 5. Yeah, those are some doozies. So let's see the final project. Okay, so estimate the average cost of the travel for a family in US dollars using the mean number of freights purchased per family. Don't overthink this. This one is actually very easy. It's simply just the average number of freights, which you should have gotten from question 1, right? So question 1, you use, you've got sets of data. So you've got 3 different probability distributions that are your data sets that you run. And if you run the summary statistics using the probabilities as the weights, you're going to get means and standard deviations. You want to use the mean for the number of, I think it's the number of, let's see, estimate the average cost of travel. So the number of freights, right? Using the mean number of freights. So you want to use the mean number of freights that you calculated from part 1, and then simply multiply that by the 2000. And then that gives you an approximation, right? So like if you ran the numbers and let's say the mean number of freights was 3, then you would just simply do 3 times 2000, and you would say, in today's dollars or whatever, it would be an average cost of 6,000. Yes, if I mentioned this before, if you run the probability distributions in SAS, you'll get a different answer for the standard deviations than if you do it in Excel. I honestly don't know why it does that, and I don't know how to make SAS give you the same answer, because it's obviously doing something wrong. Because if you use the formulas for calculating a standard deviation of a probability distribution and you do it in Excel, basically, by hand, by, saying this equals this times this and blah, blah, and doing all those steps, you're going to get what should be the right answer. And when you run it in SAS, you get completely different answers. And I have Google searched until my fingers were bloody trying to find, how to get the standard deviation of a probability distribution in SAS. And it seems to be the way that we're doing it, but it doesn't seem to be working. So if somebody can figure it out, I would love to see it. But at this point, I would say don't worry about it. You know, what's the point of that question? Well, the point of that question really is to make sure that you can get the means. Those are the most important things, because the standard deviations really aren't that important. We really don't use them very often when we talk about probability distributions. 2, it's to make sure that you know how to use, you got different means as well. Oh, well, that's a problem. Okay. Well, let me open up the data. Let's see, we want, okay, so here's the data, right? To do the mean, it's simply the X value, right? This is considered our random variable. Our random variable is families per parish, and it can take on these 6 different outputs, just like our freight random variable can take on these, 8 different things, and number of families can take on, number in families can take on 9. To find the mean or the average, right, of a probability distribution, all you do is take the value of your discrete random variable, i.e. the X, multiply it by its corresponding probability, which is what we have here, and then you sum all them up. So all I did was I defined this first cell to be this cell times this cell, and then I just, grabbed the corner and drug it down, and then down here just summed it up, and that's your sum. And you do that for all of them. And then if you use the formula for figuring out the standard deviation, which is each probability, right? If you look at this, and if I look at the thing, it's all this stuff, right? So what you do is you take the probability, you multiply it by the difference between, so you basically take the X, subtract the mean from it, square that, and then multiply it by its probability. So that's what you can see I'm doing here. I've got A2, which is this number, minus the mean, which is C8. I've just got a dollar sign here, so when I drag it down, it doesn't change to C9, C10. It stays, the dollar sign says keep 8 from moving. So it's, the next one's going to be this one minus C8, and so on and so forth. So I take that difference, I square it, and then multiply it by its probability. Do all of that, and then you sum them all up, just like you do for the mean, and that gives you the variance. Then you take the square root of it, and that gives you the standard deviation. For some strange reason, if we do this exact same thing, if we run summary statistics in SAS, we get a standard deviation of like 0.59. It's completely and totally different. And I don't know why. It's very frustrating. As far as the final project is concerned, I have on my answer key both numbers, and I will accept both numbers, because to me, it's not important that you get the right answer. It's that you know how to do the work in the technology. And if you did it in SAS and got the wrong answer, that's fine. That's the technology falling down. You did what you were supposed to do. If you can get the right one out of SAS, that'd be awesome. I'd love to see how. All right, Kofi, your hand's still up. Do you have another question?
Yes, I did. I was trying to see how the part 2 can be done in SAS as well.
Part 2?
Mm-hmm.
With all the judges?
Yep. Is it possible?
It can't be, no.
It can be, okay.
Part 2 really has to be done in Excel.
Okay.
Yeah. All right. Anybody else? I think I saw somebody come off mute a second ago.
I was going to ask, how did you get the cell to multiply times the next cell? I never done that before, so I was trying to figure out how you did it by watching without asking.
So you're talking about this?
Yes. How'd you get it to equal at C?
All you have to do is type in, well, you don't even have to type in. So you put in equals, because you're going to define, anytime you want to do a function, it's always equals. So it's just going to equal, and then I click here, and then you put an asterisk for multiplication, then you click here and hit enter, and that equals that. Now the thing with Excel is position based. So this cell says, take a cell 2 to your left and multiply it by the cell that is directly to your left. It has nothing to do with the letters and the numbers. It's all about the position of this cell. So because I put the formula here, it says take right next to you and then 2 away, multiply those together. So if I take this corner and grab it and pull it down, it's going to copy that pattern. So now if I click on here, you can see that it's A3 times B3. Again, it took the 2 cells next to it and multiplied them together. That's why in this formula, where I need it to take the X and subtract the mean from it, I have to put a $ in here, because otherwise, if there's not a $, it's all positional. It says, hey, if we're living in this cell, I take the number that is 3 cells to my left, and I multiply it by a number that is 1, 2, 3, 4, 5, 6 cells down and 1 cell over. So now if I were to drag this formula down without having that $, it would take the 2 and it would multiply it by this empty cell here, because everything shifts down by 1. And then when I got to this cell, it would take the 3 and multiply it by this empty cell. So in order for it to not move this cell in the formula, you have to put a little $, and that holds it steady. And so as I drag it down, it's still changing. It's grabbing the new number because that thing is positional, right? That's this A2. Then the next one becomes B2 or A3 and so on and so forth. And the same thing, multiplying it by B2, this whole multiplying by the thing next to it, that's going to move. So these 2 positions will change. This one won't.
Okay.
Is that, I mean, it's Excel is very positional. It's very basic, right? So the basic ones are easy. It's just equals this times that. So for instance, when you're working on the part 2 data and you want to do everything in Excel, you only have to do one thing and then drag it, right? So this is probability of an appeal. Well, the probability of an appeal for this judge is simply the number of appeals that judge has had divided by the number of cases that judge has had. So it's going to equal the number of appeals that judge has had divided by the number of cases that judge has had. And that's the probability. And we can turn it into a percentage, give it 2 decimal places. And now this cell says, right, go 2 to my left, divide that by something that's 4 to my left. So if I take this and drag it down 1, and I look at this function here, you can see that it's using these 2 cells because it's moved down. And if I take it and drag it this way, it doesn't work because now it's the 2 cells have moved, right? It's 2 to my left and 4 to my left. So it's this number divided by that, but that's not a number, right? So that's what I mean by it's all positional. If you drag things around, it'll always do things based on position. So that's how you can get these done really quickly, because now all you have to do is drag this all the way down and it'll do all of them for you instantly. Okay?
Dr.
Okay.
McBride, I think I was trying to use the function of the STEV. There were a couple. I think I tried the .p or so for standard deviation.
Oh yeah, but
really
standard
didn't
deviation,
figure it out.
no, the standard deviation function only works for a set of actual numbers, right? So equals STD, this thing, right? So this .p is if you have a population, and .s is if you have a sample. But either one is not going to work because you need to give it a list of numbers. So okay, so I can give it this list of numbers, and then what am I supposed to do? Comma this list?
That's what I was trying, which I think is why I was getting different numbers again from
Yeah.
SAS, so
Y-
for the
yeah.
mean and the standard. Okay.
So what that's doing is that's actually just giving you the standard deviation of those numbers as if they were a set of numbers. That's what
Just a separate
yeah,
step. Okay.
that's what that does. That's basically just doing your basic summary statistics on a set of numbers. Whereas here, we don't have a set of numbers. We have a set of numbers that are weighted, right? They show up with a certain number of weights. So that's why it doesn't work.
Okay. That was going to be my question on number one. When I put it in SAS, I had to put with the at the bottom the weighted,
Exactly. You have to
but I
weight it
didn't
by its
know how to do
probability.
that while it was in Excel.
Yeah,
Okay.
it doesn't work in
Yeah.
Excel.
Thank you.
Okay, Cecily.
Thank you. Please forgive, but 4.65D, I know that you so beautifully explained this Monday, and I thought I took very good notes. And when I tried to figure everything, no, I was still lost. So if you could help again, because I know that we're trying to, first we have to find our, oh, wait a minute. Maybe I've confused my notes. I'm lost.
Okay, so the idea is all they're asking in concept, all they're asking. Now, in application, it gets, it's going to take a couple steps, but the concept of this is very simple, and you should be able to draw a picture and understand what's going on. And what it is here's your mean, right? And this is saying if you take the mean and you add a certain distance to it, i.e. this distance here is k, and then you also take the mean and subtract that same distance from it, then all of this area is 60% of your data. And they want us to figure out what that distance has to be in order to be 60%. Now, if they asked us something easy like 68%, we would know that the answer would just be 50, because the empirical rule tells us if we go one standard deviation in both directions, and our standard deviation right now for this set is 50.
50.
So if we go up 50 and down 50, right? So if we went up to 300 and down to 200, we would have roughly 68% of our data in that range. Well, they didn't ask for 68, they asked for 60, those jerks. So we have to actually figure it out. We have to do some math. Well, we have two functions in SAS and in this class in general that deal with the normal curve. We have the normal CDF function, and if it's in Excel, it's the one that's normal.dist, right? If it's in your calculator, it's the normal CDF function. If it's in StatCrunch, it's the normal calculator, right? They all do the same thing. In SAS, it's the code. Oh, I'll get there eventually. Right here, it's the CDF normal function.
Okay.
And that function gives us the area under the curve to the left of a number. What number? X, right? We tell it X, we tell it the mean, and we tell it the standard deviation, and it gives us the area under the curve to the left of it. So visually, it's doing what this thing is doing right here, right? So for instance, 250, 50, 350, that visually is what SAS is giving us if we put those numbers into that function. It accumulates, a cumulative function, it accumulates all of the area from the far left up to that point X.
Okay.
So that's the one function we have. You give it a number, it gives you area. Then we have the inverse function, the inverse norm function, which in SAS is called the quantile function. In the graphing calculator, It's the inverse norm function because that's exactly what it does. It does the inverse of the norm function. And in Excel, I think it's also called the inverse norm function. And it does exactly that as it goes backwards. Oh, so it's norm dot inverse is what it is in Excel. And what all of these functions do, whether we're doing it in SAS or calculator or whatever, these functions go in the opposite direction, right? So if you remember what a function is in general, right? A function is a question and answer machine. You give it an input, you crank the handle, it spits out an output, right? Think of like an old meat grinder. You stuck some beef in there, you crank the handle, you get hamburger, right? You stick some pork in there, you crank the handle, you get sausage. You stick ass, hoof, and feet in there and crank the handle, and you get a hot dog. That's a function, input and output. Well, what the quantile thing does is it goes in the opposite direction. So instead of putting beef into it and spinning the handle and getting a certain type of sausage link, the quantile function says, tell me what kind of sausage link you have, and I'll tell you what kind of meat went into it, right? It goes backwards. You give it, instead of an X value, you give it a probability. You give it a P value, which is the probability, which is the same thing as area under the curve. So you're basically saying, find me an X value such that 20% of the data is to the left, right? Because everything is to the left. It's the inverse of the CDF, and the CDF gives you area to the left. So the quantile function works with area to the left. So this is basically saying, if you know how much area you want to be to the left of you, and you know the mean and the standard deviation, then I can tell you the X value that gives you that amount, right? Gives you that amount of area. And that's the one we need to use here, because in this situation, we know the mean, we know the standard deviation. We don't know the X. The X is what we're trying to find, right? We're trying to find these values. But what we do know is we do know the area.
Okay.
So for instance, if we want to find this lower value, let's say we want to find the left hand. We want to know what this X is. Well, that's simple. We just need to know how much area is to the left of it, and then we can use the inverse norm function. Well, if there's 60% here, then we know the two tails have to add up to 40%. And we know that it's symmetrical, so this has to be half and this has to be half. So we know there has to be 20% here, just like we know there's 20% up here.
Right.
So we can run the inverse norm with 20%, and it'll tell us what that X is. So here, I've already got it set up. 20%,
Okay.
the mean is 250, the S is 50. If we run this function, it
It's
says, okay, 207.919.
Okay. That was wrong. Okay.
So now that means X is 207.919. That's X. They didn't ask us to find X, they asked us to find K. Well, that's fine, because K is just the distance between these two. So K is literally just 250 minus 207.919, right? Because that's the distance between those two numbers. And so you do that, and you get 42.081. So just 42 is fine, right? But that's the idea. That's how we get it. We have to use that inverse norm function, or in SAS, it's called the quantile function.
Okay. All right. I made this much more difficult than it needs to be.
Oh my God, you're a typical student then.
Okay.
So just remember that when we're dealing with the normal curve, we only have two functions, right? We have the function that if we know the X, it will give us the probability, i.e. the area under the curve, or if we know the area under the curve, it will give us the X. Those are the only tools we have to work with. So it makes it pretty easy to try and figure out which tool you're going to use, because you've only got two of them.
Okay.
All right. Anything else?
No, I think That makes sense now, and my notes make better sense now too.
Good,
Okay,
good.
thank you.
Yep. Okay. Seth.
Hi, can you hear me?
Yes.
I had a question about 4.72, or actually any of the ones with percentile in general. I feel guilty the way I actually got my answer. I think I got the right answer, but I used a normal calculator online and then kind of worked backwards from the percent. And I know that's not correct. I was hoping you could show me like the legitimate way to.
Okay. So with
go about
these
it.
types of questions, you want to draw a picture, right? Always draw a picture, kids. It really helps. Because if you can draw a picture, you can visualize what the heck is going on. An honor society wishes to invite those scoring in the top 5% on the college boards to join their society. What score is required to be invited, right? So we need to know a score. Well, that means we need to know what X is that has 5% above it, right? Top 5%, which means, of course, 95% below it. And then we have to use, this information because it says refer to 470 because we need to know what the mean and the standard deviation is. So we've got a mean here and a standard deviation of here. So this is a situation where they gave us a percent and they want us to find an X. So which of the two functions in SAS are we going to use?
The quantile function.
You got it, Cecily. Very good. So in this case, all we have to do is change everything, right? So this is now 95%. And the mean, I think, was 513. Questions, 513 and 130. Okay. So 513, 130. And there is my S value, right? They give you the P value, which we already had. They give me the mean, which we already have. Sorry, they give me the standard deviation, which I already had. And then there is my X value right there under value. So 726.831. And that's literally the answer, right? Because that is the value on our little picture. So that gives us 95% below or 5% above, which is what they're looking for. And then when they say what score separates the top 75% from the bottom 25%, well, then for that picture, we're now looking for an X here that has the top 75% separated from the bottom 25%, i.e., as someone had said at the beginning of class, isn't that, what do we call this? Well, we call that the lower quartile because it's the first quartile or the lower quartile because it separates the first 25% from the rest of our data. And we would figure this one out with the exact same program, right? The exact same code. The only difference is instead of having 95% of the data below it, we only want 25% of the data below it because we're looking for that first quartile. And there it is, 425.316.
Thank you for going over that. While you were doing it, I actually realized why I wasn't able to do it in SAS before. Because I wasn't copy pasting the code. I was writing it out each time. And I
Yes.
didn't have one of the variables, the XMS. I had XMS instead of the P and M and S.
Yeah.
So, okay.
Yeah, it's
Thank
really,
you.
yeah, that's why I copy and paste because it's just too much room for error.
Thank you so much.
Of course. Kofi, your hand's still up. Do you have another question?
Yes, not a question, but I crave your indulgence. If you could do the probability for part 2 in Excel again for me, and if you could go a bit slowly.
Which one? Are we talking about?
How to do the part 2 in the final. So you did it already, but I was just asking if you could do it a bit slowly.
All right, so let's do this one. This one here is probability of a reversal. I'll make it bigger so we can read it. Well, a probability of a reversal is simply going to equal number of reversals divided by number of cases, right? It's always good over total. To define a function always starts with equals. Well, what is it going to equal? It's going to equal reversals. So I click on that cell, divided by, which is just a little slashy thing, because that means divided by the forward slash. And then it's divided by total cases. So I click on that cell, and you can see that it writes in E2, B2. I could have typed in E2, B2 as well, but I just click because I'm lazy. Hit enter, and that is now defined as the probability of a reversal for that judge. Now we could do it all over again. The next one equals this judge's reversals divided by this judge's cases, and hit enter. Click on the cell, come up here and hit the little percentage symbol, which turns into percent. And then of course, this little thing increases decimals, right? So if you hover over it, it pops up the little thing that says, hey, this increases decimals. So I click on here 2 times to give ourselves 2 decimals just so we can see something, because otherwise it just says 0%, which, you know, it's like, that can't be 0%. And now we've done it again, and we can keep doing this over and over and over again. Or with Excel, they've got this lovely little thing called fill, with an F, not Phil like, you know, Mickelson. And when you move your cursor to the corner, you can see there's a little green square in that corner. When you move your cursor onto it, it turns into little black crosshairs. You can now hold down the mouse button and drag, and you can see the green box is getting bigger and bigger and bigger. And what it's going to do is it's going to continue that pattern. It recognizes that you want Excel to take the reversals divided by total cases. And since those numbers are in the same place everywhere in the 2 columns, it can continue that. So you just drag it down for the whole list, and then once you release, it redoes that. So for instance, if I click here, we can see that it took that cell divided by that cell, which is exactly what we want. Guys, if you don't know how to do this in Excel, I don't want to sound like a dick, but shame on you. For crying out loud, we're in 2021. Excel is by far the most commonly used program amongst all employers. And there is almost not an employer on this planet that doesn't want their employees to have at least basic Excel skills. So if you don't have them, you better go out and get them, because you ain't going to get a job without them. I mean, I'm serious, guys. If you learn nothing else from me in this class, hear what I'm saying right now. There is nothing more important than decent Excel skills in the marketplace right now. It is seriously paramount that you know how to work in Excel. Oh yeah, pivot tables, all that stuff. Now, granted, there are jobs out there that don't deal with data at all, and you can get away with not knowing how to deal with Excel. But the vast majority of decently paid jobs, i.e. jobs that people with a friggin' doctorate are going to want, right, are going to deal with data. So you need to know how to play around with Excel. So I suggest start playing, because that's the best way to learn. Fine, go out and watch some YouTube videos. Those are great, but get in the data. Just get down and dirty. You can't break it, for crying out loud. Just start playing around and figure out what you can do. I have learned so much stuff just from futzing around. I've got I do all sorts of cool functions and formatting and weird stuff in Excel. Just because I need to do things, like I had copied a bunch of data into an Excel spreadsheet, and everything that I had, I only wanted the last 4 things. So there was all these, like for instance, if I wanted just this please, and I didn't want the comment in here, there's a function that'll do that. That'll basically just capture the last 5 characters in a cell. And so there's all sorts of really cool stuff you could do that you really need to know how to do in a lot of jobs. Somebody asked if the rankings are your opinions. Yes. There really are probably 3 logical ways that you could rank the judges. You could rank them based on who has the lowest probability of having an appeal, who has the lowest probability of having a reversal, or who has the lowest probability of the conditional reversal, right? Which is just the probability of a reversal given an appeal. So basically, what's the probability that their ruling gets reversed given that it's already been appealed? Which is kind of a stupid question because I'm not a lawyer, but I didn't think you could reverse something without appealing it. So I thought you had to appeal it in order for it to be reversed, but maybe that's not the case. I should ask my friend, he's a lawyer.
It is 2020 or 2021.
Yeah, that's right. Stranger things have happened. Yeah, exactly.
Exactly.
The rule of law seems to no longer apply to the natural world. So you're absolutely correct. Right. Yeah. But in any case, those would be the only 3 logical ways that you could rank your judges. So just pick one and then rank them accordingly. Okay, Kofi, did I go slow enough? Did you catch how to do that one?
Excellent.
Thank you. Perfect. Seth. Okay, Seth.
My mistake.
Okay, that's wrong. Your hand was up for nothing. That's fine. Michael, I see you're off mute. What do you got?
Yeah, I do have 2 questions. One, with the rankings.
Yep.
Can we order those by sorting them?
I would prefer, and this is only because it's how my answer key is, I would prefer that you keep everything sorted by judge.
Got it. Okay.
And then that way, when I look at your rankings, they will match up with mine. And more importantly, your probabilities will match up with mine. So please keep them, right? You're going to do them each individual one. So I've got the master sheet, but you'll want to do each individual court and leave the judges sorted by their numbers, please. I'm so glad you asked that, Michael. Thank you, because that makes it so much easier for me to grade.
Understood. And the
Yep.
other question was, and this is more of a sidebar for me, with your feature of the pen, you know, how you are marking on the document.
Yes.
Is that an add-on? Am I missing something here? I was trying to do this today with one of my instructors. I'm like, I'm a freaking moron. So Dr. McBride.
There, you have to have some sort of stylus and input device, and I have one by a company called Wacom, WACOM. They seem to be kind of they seem to be the gold standard for stylus and input devices. They have the really expensive ones for artists where you can, draw digitally, and then they have the cheaper ones for people like myself, teachers and educators. So go to Wacom, WACOM. I mean, you can go to I got cheap ones off of Amazon that work fine too, but I mean, Wacom has a really nice one that's only like $50. And that's basically what I have. So I have this big thing that it looks like an iPad basically, but it's not a digital screen. It's just a surface. And then I have a stylus, which of course just looks like a pencil. And once you have that installed, then the draw, you can add the draw menu to Word, because I don't think it's standard. I think I had to go in there and I had to add the commands, but if not, it might be standard. But usually if you don't have a stylus attached and you try and draw, these things are just kind of grayed out. Or sometimes it'll let you and then you're trying to draw with a mouse, which is just friggin' impossible. And then of course you can draw with touch if you have a touch screen. But that's all I'm using. So I'm just using a Wacom tablet. And I got an old one. It's the bamboo tablet, and I'm lucky because the bamboo tablet is super huge. Because the new ones, the writing surface area is normally like 4 or 5 inches wide by like 3 or 4 inches tall. This old the old bamboo, and if you want to try and find one online, it's the CTH 670. I'll write it up here. It's the bamboo CTH 670. Mine broke along a couple years ago, and I found it, I think on eBay for like $50. And the nice thing about it, like I said, is it's much bigger than the new ones. The new ones are all small and light and compact because people want to travel with them. I'm not going anywhere. I got this big hunk of thing just sitting in a drawer, and whenever I teach, I bring it out, stick it on my desk, plug it in, and it's got, oh, it's like 10 by 6 is its writing area.
wow.
So yeah, so it's great, especially when I have dual screens. Because if you have dual screens, the writing area is now spread across both screens. So if I want to write on my left screen, I have to have my stylus over on the left side of the writing area. And if I want to write over here, I'm now on just half of my writing area. And if your writing area is, only 4 by 3, you've got a pretty tiny writing area if you have a dual screen setup. So those are some things to think about if you want to use this kind of stuff. And if you're going to teach online at all, you're going to really need to invest in this, because unless you're teaching history or something, philosophy or something that's just a lot of talking, you're going to want to probably draw and write some things.
And you said this is Wacom, WACOM, correct?
Yes, yeah. The company is Wacom, WACOM. I know some people call it Wacom. I don't know how it's pronounced. I always like Wacom because it sounds like whack-a-mole, but it's literally just wacom.com, and you'll find all sorts of them that, there'll be really expensive ones and the really cheap ones. Yeah, there's somebody's got it right there that Cecily put it up in the chat board.
My
Thank you, Dr.
dad has
McBride.
one because he doesn't type well, and
Yeah.
so he does it. And he has an old one, and then set it so he can convert it to his text.
Yeah, they have a great feature with the right software. You can handwrite, and then it will convert it to text. And this is something else, guys, that's just, since we're off topic anyway, for those of you that are going to be writing a dissertation here soon, and if you're anything like me and you hate to type and you're not a fast typer, it is well worth the money to buy Dragon Naturally Speaking. Then you basically dictate, you talk into a microphone, and it turns your speech into text. It writes it, and it works in multiple applications, including Word. So you can just open up a Word document, turn on Dragon Naturally Speaking, and just start dictating, and it's just writing along as you're dictating. And sure, certain things, it'll have some typos, and it'll pick up, the wrong there, and there, those kinds of things. But you just go back and do a quick edit, for anything, just do what is it, grammar and spell check, and you'll find most of your mistakes anyhow. And will it transcribe video? I don't know. I've never tried that. It might, because if you can, what it does, Dragon, normally you have to teach it to understand the way you speak. So you narrate. It has when you first buy it, it has like a little paragraph, and you're supposed to just dictate the paragraph. You just read the paragraph out loud, and it's listening to your voice and your accent and how you speak, and then it figures out your speech patterns so it can better do the words that you're saying. So I'm not sure that would work unless the video was in your voice, but it might. If you can set it up so that the video speaker is speaking into your microphone. Yeah, and there you go. Screen-o-matic is another option. I mean, I think there are better tools for transcribing videos. For one thing, YouTube transcribes videos pretty damn well. So if you create a YouTube channel and upload your video to YouTube, in about a day or so, it will be closed captioned, i.e. it'll be transcribed. And then you can download the transcription as like a text Word file, and then edit it if it's wrong, and then upload it again. So then I've had to do this with my videos, where I'm saying some math things, and the closed captioning is like dirty words because it sounds like a dirty word type of thing. So I'd have to go in there and I would change it and those kind of things. But yeah, so YouTube is a great free way to get things transcribed as well. And those are just some tips for writing your dissertations that I can think of. Okay, back to what we're doing. Any questions on this stuff?
I have a question about kind of these graphs you were drawing when you were using the pen. So we should have drawn multiple graphs for part 6, like one for part 1.
Okay,
2,
so
3,
part
and 4,
6,
or
yeah, you're supposed to draw a graph for each one of the questions, right? So for instance, you're basically doing you're doing versions of this question, right? So part A, I'll do in blue, would look like this. What's the mean? 930. Okay, so right? And then B, I'll do in red. B would look like this. Right? And then C we'll do in black. Come on, get over there. And C, we want what is the 90th percentile? So that would be X such that this is 90%. Right? It's that kind of.
thank you. That
Yeah,
helps.
yeah.
I was way off. I had one of those pens, and I drew a graph, and I put, for some reason I was putting like the empirical rule, like I put what was 68%, 95%, and 97 in the different colors. But as I was just rereading it today, I'm like, graphs. So it says numerous graphs. So that's what was making me think a graph to show each part there. Okay.
Yeah, it just wants a visual representation of each of the
Of each
probabilities
result.
that you're computing. Basically exactly what you would get out of StatCrunch if you were using the StatCrunch calculator, because it always
Yeah, I
shades
didn't have
in.
access. I think I could have got it because it said if you're a teacher, you can get it. But
Yes, I
I'm a
believe so.
teacher, but I'm not technically like a math teacher. So I'm like,
It doesn't matter.
I
They don't
figure,
know.
but
Yeah.
okay.
In
maybe I'll
fact,
just
you know,
get it
I
then.
think if you have an
My drawing
EDU,
sucked.
yeah, as long as you've got an
I got an EDU email, so I figured
yeah,
I could get it.
you could probably
Yeah.
get it. Yeah.
Okay, I'm sorry to butt in. I'm confused. So for that question, were we supposed to be inserting these graphs?
No, not for
Yeah,
the
for
homework
number
question. She was
6.
talking about for
No, for part,
for the final
Yeah, I
project.
part 3.
Okay, I think, yeah, I think
Part
the
3.
going back
Sorry,
and
I
forth
moved on
between,
to the
Yeah.
project.
yeah, the
down
going back
here.
and forth between the project and it's kind of confused me. I'm trying to focus on because
Yeah.
I can't do the project completely if I'm not understanding the homework to know what I'm doing. So
Sure.
that's where I'm lost.
Yeah.
Okay, thank you. All righty.
Okay. Anybody else? Alice. Sorry.
Hi, how are you, Dr. McBride?
I'm fine, Alice. How are you doing?
I'm doing okay. Can we talk about the very last question?
In what?
I know we talked about it before.
The homework?
Yeah, the homework.
Okay.
And I kind of went back and forth. I got kind of confused on which plots. I know we did this on Monday, but I kind of got confused on what plots go where. And yeah, so I was actually having issues with both A and B on that one.
Okay.
Thank you. And if my dogs start to bark, I'll go on mute. I have to. They're very loud.
Okay, so here is the data for 94. I'll just rerun it so it loads it and it puts it in the work import folder. And then we want to do distribution analysis is how we get the QQ plot. We're in the work import folder, so we have to add in our variable, our toughness variable. And then I think it's under options. Yeah, so you can tick off histogram because you don't need that one. But you want to check for normality. And how do we check for normality? We do the normal QQ plot. You can do these other things too, but all we care about is the normal QQ plot. Once you do that, it asks you if you want to inset the statistics. You go, yes, please. And then down here, it says, okay, what statistics do you want to inset? So you open up that and you go, well, I want to do a goodness of fit test.
Okay.
Because that will give me the correlation and the p-value. And that's all you got to do. And then run it. There's my QQ plot, right? Obviously,
Okay.
if I zoom out, well, I'll get it all in one screen so I can copy and paste it. And then up here, your normal test statistic, that's your correlation, and this is your p-value.
Okay, so I guess I was confused. I was thinking, does that one thing answer both questions? So
It does.
I guess it does.
Yes.
Okay.
Yeah, as long as you do the inset statistics, it answers both for you.
Okay. All right. Thank you. Like I said, I was kind of.
No problem. That's what we're here for.
I was reading more into it than I needed to.
Yeah. Okay. What else?
Okay. Well, since no one else has a question, can I ask another one?
Sure.
Can we look at 88C?
Repeat the exact probabilities corresponding normal approximations with continuity correction for this. Yes. Okay. Well, obviously, exact probabilities is easy, right? Because you're just finding the values in between 8 and 4. And if you're going to do it in SAS, you just have to do it in 2 pieces.
Okay.
So you would have to, because to get in between 8 and 4, you have to do the binomial twice, right? So here's the binomial CDF.
Okay.
And you got to be careful because it wants strictly between 8 and 4. They were strictly less than or equals to, or less than and greater than. They weren't less than or equal to. Okay, now the question gave us a number of 20 and a mean of 5. All right.
Okay.
So we've got 20, mean of 5, and they want us to be in between 8 and 14. But again, I said it again, and I'll show it again.
Right.
Strictly greater than 8, strictly less than 14. So if we think about that, that means we're looking for the set of probabilities for 9, 10, 11, 12, and 13 only. Right? So we have to do the CDF of 13, which gives us 0 through 13. Then we have to subtract the CDF of 8 from it, because that gives us 0 through 8. And if we subtract 0 through 8 from 0 through 13, we're left with 9 through 13. So we have to run this twice with the 13 and the 8 to get the right probabilities in SAS.
Okay.
And that's all you got to do is first run this with a 13.
Right.
And then run it with an 8, right? So I'll run it just once, just so we can see what the 13 gives us. So there's the probability of 0 through 13. Run the 0 through 8 and subtract it. That will give you the precise answer.
Okay. And when I do the 8, I can do the 1 minus CDF, right? And that would give me the.
No, you don't want to do 1 minus. You just want to do 8.
Oh, I just want to do 8. Okay.
Yeah, because 8 gives you 0 through 8.
Oh, that's right. I'm not looking below. Okay.
And then you subtract the 8 from the 13.
Oh, I see. Okay.
Because that gives you the 9 through 13 left over.
Okay.
All right, so that's how to get the precise one. Now to do the normal one, right, to do the normal approximation, we have to do it with the corresponding continuity corrections. Well, again, draw a picture to help yourself. Right, we have all of these bars that represent what we're looking for. 9, 10, right, 11, 12, and 13. And each bar is centered on those numbers, right? So 11 is right there, 10 is right there, 9 is right there. And this is all we want. We want 9 through 13. Okay, well, the normal curve, to approximate it, we don't want to go between 9 and 13 because it would cut this bar in half and it would cut this bar in half. So what we want when we're doing the normal approximation is we want to correct for this continuity, right? And we want to start here at 13.5, which is technically, it's right here, it's right on the edge. And then right here on this edge is 8.5. So we're going to find the area between 8.5 and 13.5. So if we go back and run the normal probability distribution, up here, first thing we'd have to do is calculate the mean and the standard deviation. Well, the mean is easy, it's just 10 because it's 20 times 0.5. And then the standard deviation is going to be the square root of 5, which you can actually type in as the square root of 5. You can do SQRT 5.
Mhm.
And then the mean is 10. And then we want 13.5 for the first one. We run that. And there's our probability for 13.5. And then, as you can see, it's pretty darn close to the binomial for 13.
Mhm.
And then if we go back and do the low end, right, which is 8.5,
Mhm.
and again, change this one to 8, we'll see that they're similar. So there's 8.5, there's 8, again, very similar. And remember, we're just doing a subtraction. So you take that first one, subtract this one from it, just like you took the other first binomial and subtracted this one from it, and you get your approximation. And since both of these were very, very similar, you can see that the approximations are going to be very, very similar as well.
Fantastic. I appreciate that. Thank you very much, Dr. McBride.
Of course. Kim asked us to discuss part 3 of the final project. She's trying to figure out what to use for the scenario. Well, that's the whole thing that we talked about, that I wanted you guys to send me your scenarios this week so I could tell you whether or not it works well. The scenario can be anything. You can make it up, right? You can completely make up this whole thing. Ideally, you would use a scenario that is from your dissertation or related to your dissertation, right? It's on topic. It's what you're going to be studying, what you're going to be researching. And all you have to do is come up with a research question, right? Something that you want to try and investigate by gathering data, such that the data that you gather is continuous. And in order to gather continuous data, it's just necessary that you are measuring and not counting. So quite a few people have been sending me scenarios that are not applicable because they are counts instead of measures. And it's unfortunate because a lot of our research, you all and myself, deals with discrete data. You know, you're dealing with human beings, and with human beings, you tend to count things more than you tend to measure things. We don't really care about people's heights and weights. We're more often concerned with how many times did you use illicit drugs in a month, right? How many times, was a child violent? It's usually we're counting things that we're then trying to come up with certain what we call interventions, which is a fancy way for a new technique to try and mitigate those situations, right? A new addiction treatment for people that are using drugs, a new anger management treatment for teens that are acting out, So the data that you gather in these types of social situations, and in education, it's the same, they tend to be discrete data. So unfortunately, it's probably going to be very difficult for you to come up with a scenario that is strictly related to your dissertation topic that is going to involve a continuous random variable. If you're lucky enough to have a topic that involves that, then great, go for it. I did my dissertation on new teacher training programs and which training programs were more successful at keeping teachers teaching longer, right? So one of the variables I looked at was how long until a teacher left the profession. Well, that's a measurement. That was a continuous variable because we were measuring time. Even though most people would report that in a discrete, they would report it as number of years they taught or even number of years and months. It's still a continuous variable, so you can treat it as a continuous variable, and you can run probabilities using a continuous random variable technique, i.e. like the normal curve. But a lot of the data I gathered was discrete, and a lot of the data I gathered wasn't even numbers. It was, qualitative. And I'm sure the same applies to you guys. So if you can't find a scenario strictly tied with your dissertation that will result in a measurement that, i.e. results in continuous data, then either tweak yours, right? Come up with something tangentially related to your dissertation that would involve a continuous random variable, or just make the whole darn thing up. Just come up with any fun little scenario you want to come up with that involves measuring something. Because the scenario doesn't matter. It's all about, as far as what you're supposed to learn with this, it's all about being able to do the rest of everything, right? And these first 5 questions, in my opinion, are the more important questions than 6. 6, you're literally just redoing what we did in the homework. You're only doing it with your scenario and your numbers, right? So for instance, find the probability that a continuous random variable is greater than a specific value pertaining to your problem. Well, that is literally the exact same question as this one, part B. What's the probability that their score is greater than, instead of some made up number, greater than 960, right? So all of those questions are just going to be mimicked questions that we are already done in the homework. So to me, you're not really learning much there. And in fact, I think this whole question from a statistical learning standpoint is really kind of stupid. It doesn't really teach you any statistics. But what I feel is important about this question is it gets you running through the process of identifying a problem, constructing a specific and I want to say measurable, but it doesn't always have to be measured, but a specific and statistically, analytically, you're able to statistically analyze a question about that problem and then go about, fixing it. So the idea is, okay, the problem I've identified is teen violence. All right, let's be more specific. Teens with learning disabilities, seem to have acts of aggression more frequently than teens without learning disabilities. Okay, so I've identified the problem. What do I want to do? How do I fix it? Okay, well, I've read a paper out of the Netherlands where they've found this new technique of introducing them to meditation really helps lower their acts of violence. All right, well, it worked in the Netherlands. Let's see if it works on American kids, right? Because we're totally different than the Dutch. So there's my research question. Can meditation lower the number of violent episodes in teens with learning disabilities? That is a well-defined and researchable question. It says what I want to fix. It says what I'm trying to see, and now I can figure out what kind of data do I need to collect. Okay, well, I need to go out and I need to collect data on acts of aggression in teens. Well, I better define what an act of aggression is, right? And then what are the possible variables? Well, I'm going to want to collect how many times that they show an act of aggression in a certain period of time. Maybe we're looking at weekly, monthly, whatever. I want to probably collect their gender. I probably want to collect their age. I probably want to collect their ethnicity, their socioeconomic status, and I want to collect what kinds of learning difficulties they have, because these are all the things that could possibly have a bearing on whether or not they have acts of violence. And then once I gather all that data, what kind of methods would I use to analyze that data? Well, if I want, and then of course with all those people, I need to count up how many times they're violent. Then I need to, give them this meditation protocol, and then I have to go back and again measure how many times they're violent. I want to see if there's a difference. Well, how am I going to analyze the data? Well, in this case, I'm looking at pre and post, right? Before the instrument, before the thing that we did, that I'm now blanking on what I call it, the protocol. Before we do that, intervention, damn it, that's what I was looking for. Before the intervention, they had, X number of violence. After the intervention, they had this many. So that's going to be a paired t-test. I'm just going to do a simple paired t-test to analyze whether or not the intervention had an effect. Then I could also run a chi-square analysis looking at the categories, where I could look and see, is there a difference in the amount of violent acts between male and female? Is there a difference amongst socioeconomic statuses? Is there a difference amongst race, right? So to see if any of these things have an influence on whether or not they're going to be violent. Because if it does, then that helps you tailor your technique. If you find out that African American males are less violent than Hispanic males, then you want to make sure that the meditation technique is bilingual, in case some of your Hispanic males don't speak really good English, right? So it's things like that. So that's just a topic off the top of my head, but it's being able to work through that scientific process that's important. Being able to come up with a problem, come up with a supposed solution, figure out what kind of data you need to gather in order to test whether or not that solution helps, and then what statistical tools you would use to analyze that data. Now that last one, number 5, I don't expect you guys to be able to answer that a lot, because you really haven't learned a lot of tools in this class, right? You don't know what a chi-square is unless you've had stats before. You don't know what a paired t-test is unless you had stats before. We really haven't done any of that in this class, but those would be the things that you would learn later, and those would be the things that you would use later on in your analyses. Cecily.
Yeah, so I have one quick question while we're discussing this. So in number 6, when we're providing step-by-step explanations of the solution, we really don't have data. So are we making up data, or are we?
You don't have to make up data.
saying,
you just have to make up the mean and the standard deviation, right? Because to compute these probabilities, we simply just need to know that the population is a continuous random variable with a normal distribution with a mean of this and a standard deviation of this. And then we can compute what's probability that it's greater than something, what's probability it's less than something, blah, 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 blah. So you don't have to make up data. You just have to make up what the mean and standard deviation are.
okay.
Oh, wait. And now I'm confused. I made up data.
That's fine.
And then
Did you then
ran
compute
like
a mean and standard
QQ
deviation?
plot
Yeah,
and a thing. That's okay.
that's totally fine.
Or should I take that out?
No, that's fine.
Oh, because it just says describe, not do.
Yeah,
Oh.
which is fine. That's totally fine. Let me look at some chat things. Somebody had asked some stuff in the chat that was interesting. Welding students who are kinesthetic learners are more successful during in-person learning environment rather than distance learning environments. Well, yeah, that would make sense with kinesthetic learners. Are you trying to ask, Michael, if that would be a good scenario? Because it's a great scenario, but now you got to come up with, what are you measuring?
Yes, that's what I was asking.
Yeah, so that scenario seems to work. I would say you would have to, this whole more successful, that's a very vague statement. So you'd want to come up with, how do you measure success? And you'll notice that I use, how do you measure success? So if you can come up with a way of measuring their success, even if it's just a score on a test, right? Test scores are measurements. They are continuous random variables. So you could just talk about, score higher on a test than in a distance learning environment. And then that would be a scenario that would work. And then you could compare, that would give you your random variable of the test score.
Be the final grade of the class too, correct?
Yeah, the final grade would absolutely be another continuous random variable. Absolutely. Okay, and then someone had asked, are responses measured using the Likert scale considered continuous data? No, they are considered, they aren't even discrete data. The Likert scale is only considered ordinal level data. So all there is an order to it. You know that an answer of 5 is greater than an answer of 4, but that distance going from 5 to 4 is not measurable and it's not constant. Well, and what that means is if someone went from a 5 to a 4 on one question, and then they went from a 4 to a 3 on another question, that change is not considered the same. It doesn't mean they have the same lessening of their opinion, right? So the distance between 3 and 4 and 4 and 5 is not measurable and it's not constant. So another way to think about it is if one person said 4 and another person said 2, you couldn't say that the 4 was twice as much of the 2, because that doesn't make sense. It's just a Likert scale. You know, it's usually strongly disagree to strongly agree or whatever. But yeah, top box responses. I don't know what the hell a top box response is. Can you be more specific of what a top box response is? The highest response on a Likert scale. No, it still would not create Likert scale data is ordinal level data, full stop. There's nothing you can do with Likert scale data statistically other than list frequency counts and frequency counts, which of course you could then list the mode, right? And what was the most frequently, more people answered 4 on this question than anything else. You could give frequency counts or percentages, right? 25% said 3, that kind of thing. And that's it. That's all you can do with Likert scale. It's ordinal level data. People tend to report the mean of Likert scales, and that is a widely acceptable thing, but statistically speaking, it is completely 100% false, because you can't do means on ordinal level data, but people tend to do it anyways. How about sales data? Well, sales, if you're talking about number of sales, like how many things were sold, no, that's discrete. If you're talking about sales revenue as in money, then yes, money is continuous. Yeah, so in dollars would be continuous. That's a continuous random variable. Anything else?
One more question. I posted my possible topic, which now I'm afraid of that it might not work in the chat today. When will you have a chance to look at those?
I responded to a couple chats just before class.
Oh, okay. I apologize.
No, that's fine. They should be there. I try to look at them every day. I try to respond every day.
All right, thank you.
Yep.
Dr. McBride, I have a question.
Yes.
How about we're talking about continuous data? How about leadership as it affects organizational productivity?
Sorry, give that to me again.
Leadership as it affects organizational productivity, or just organizational productivity?
Well, how do you define and how do you measure organizational productivity?
I guess it depends on what's being done. The outputs could be, let's say, cars that were made or something like that, or.
Right. And so in that case, it would be discrete, because you're counting how many cars were made.
Okay.
If you measure productivity on a measurable scale, then it would be continuous. So you'd have to come up with a way to measure productivity, not count productivity. So if productivity is defined as number of things produced in any way, shape, or form, that's discrete. But if it's measured as in, quarterly revenue or daily revenue, if it has anything to do with revenue, then that's a measurement. If it's measured on, some other scale, like maybe you've just come up with an instrument that measures productivity, and it's a scale like a score that you would give an exam, then that is a continuous random variable.
And then how about savings?
How much money is saved?
Yes.
Anything that deals with money is continuous. Money is a continuous
Okay.
random variable in any form.
All right. Thank you.
Of course. Anybody else? Michael?
Yes, sir. Mine's not a question, mine's a statement. I have to say that for this class itself, I was a little intimidated, but I want to say that this has been one of the best classes I've had.
Oh, thank you. Thank you.
So just want to say thank you.
I'm glad you enjoyed it. Please keep that in mind when you're filling out your student evaluations, and please, everybody, fill them out. The response rates are usually very, very poor, and I try and tell my students, please fill them out. Even those of you that hate me and despise me, fill them out. I don't mind. Well, I do. I hate hearing the negative stuff, but I read through it, and it gives me a big pain in my heart, and I go and cry in the corner, and then I read the nice stuff, and I feel better. But yeah, fill them out. I do take stuff to heart. I do make changes based on what people say.
Are you an IPA guy?
Oh, no, I'm actually a teetotaler.
Okay, you lost me on that one.
Teetotaler?
Yeah.
It means I don't drink. It's an old phrase because they would drink tea instead of alcohol. Teetotalers. Yeah.
Oh.
Yeah.
Yeah. Well, on that note, Dr. McBride, I would say that I've learned a lot. I don't know how. I think your method works.
Yes, there is a method to my madness.
Stuff is sticking.
Awesome. I'm glad to hear it, guys. Okay, well, if there's nothing else, we can end here. I'll have the final video up